Hi, this is Mr. Max. I am going to look at a few examination examples or exercises based on probability. I'm also going to do a few other videos on this at a later date. So this is about one of three. So I'm going to go straight to the question. So the first question here says Gibson is sticking stamps to the value of 30 cents on each of a large number of envelopes. He has many 5 cents and 10-cent stamps to do this. So you will see that there is a diagram here that's going to help you to understand this concept. On the x-axis here, the horizontal axis, you have the number of 5-cent stamps. So on the vertical axis, you have the number of 10-cent stamps. So obviously the 10-cent stamps can only go up to 3 to give you 30 cents. Those are 10, 20, 30 cents. And the 5 cents can only go up to 6 of them because 6 times 5 gives you 30. So if you look at the combination that exists, because remember, he is sticking stamps to the value of 30. So he can only stick like what we have here, 4 5 cents, that is 20 cents, plus 1 10 cents, so that gives you 30. So if the question is asking for you to find another combination, all right, where you can possibly paste on the envelope in order to get a 30 cents. So one could be he just pastes 3 10-cent coins that will still add up to 30 cents, or he can paste 2 5 cents plus 2 10 cents. That also gives you 30 cents. And lastly, he can just all pull 5 cents stamps, put 5 cent stamps on the envelope. It will all just give you 6 of them will give you 30 cents. Okay. Right, so when he has finished, he noticed that there is an equal number of envelopes bearing each possible choice of stamp. So he chooses one envelope at random. So what is the probability that he has exactly 2 5-cent stamps? Obviously, that is just that 1 out of the 4, okay, 1/4. And more 5-cent stamps than 10-cent stamps. So when he chooses 4 5-cent stamps and 6 5-cent stamps, that is 2 out of 4, or 1/2. The second question here is about not my dog, but someone's dog. All right, the dog is given 11 biscuits for breakfast. 7 of them are black, 3 are red, 1 is yellow. He eats one of them, assuming that he is equally fond of each sort of biscuit. What is the probability that the biscuit he eats is red? So obviously the sum of them is 11, and there are 3 out of 11, and that is the probability that it's going to be a red. So let's talk about the same story then. He says that he eats then a second biscuit. What is the probability that the first biscuit is red and the second black, is black? So the and on probability, remember, it means multiplication. So you take then your 3 over 11, what we have, but now you're going to multiply with 7 over 10, okay? 7 over 10, because remember, he's eating one, so that one is gone now. So there are only now 10 biscuits left, all right? So what is probability that the first is red? It's 3 over 11. The second, there are 7, obviously, and then 7 out of 10. So he doesn't eat them at the same time. He just takes a second one. So it's either going to be a red one or going to be a black one. So that is the probability, 21 over 110. Now on another day, he's given 7 black biscuits, 3 red biscuits. Obviously, they still amount to 11, and he only eats 2 of them. So what is the probability that one is yellow and one is black? So there's that chance here. On the next slide, I'm going to show you how I made the 3 in order for you maybe to find how I got to solve this question. So the 1 out of 11 is yellow, plus the 7 out of 10, and then again, or he either takes the black with the 1 out of yellow, and that gives you 7 over 55. So if I bring in the tree diagram here, you can see it much easier. Remember, when you are dealing with these diagrams, when you go along the branches like this, we multiply. Okay, so when we include 2 or more branches, we add. Okay, add up. And also one of the things you understand that when you add up, that it should always add up to 1. That is 7 over 11 plus 3 over 11 plus 1 over 11 should give you 1. or 6 over 10 plus 1 over 10 should give you, and plus 3 over 10 here should give you 1. So whenever you add, the fraction should always add up to 1. Right, so when you bring that particular question back again, and I was saying what was the probability that 1 is yellow and is black, so it is that 7 over 11 times 1 over 10 because we're going along. Then add again with 1 over 11 times 7 over 10. And that is how you get the probability of 7 over 55. Right, so we have got another question here. So we have got Gervasio has 7 coins in his wallet, and he has got 10-cent coins and 50-cent coins, 6 10-cent coins actually, and 1 50-cent coins. All right, so when you look at 6 10-cent coins, that's 60 cents plus 1 50-cent coin, that's $1.10, just as a matter of interest. All right, then the question now goes and say he takes 2 coins at random. So it's better that we bring in a T diagram here and we complete it. All right, so it takes one of the other. So he takes and does not replace. That is very important. So when we complete this side here, we've got 1 over 7. Remember what I said, 6 over 7 plus something over 7 should give you 1 whenever you have this. So you can find 1 over 7 by simply saying, all right, it's not really necessary. You can simply say 1 minus 6 over 7, okay, in order for you to get this particular result. But the key is that these two should add up to 1. The same thing here, they should add up to 1 when you add them. And then you have 6 over 6, which is 1, and this one should be 0. Okay, so that is how you complete the tree diagram. It's very easy to complete it actually, and make sure that you are on the lookout for things like this when it says it takes out but does not replace. Okay, so it does not affect the total probability there. All right, so I bring it back because there's a bunch of questions here that we are supposed to complete. It says the probability that a total value of the 2 coins is 20 cents. Now, you have to be a little bit on total value of 20 cents. So it's this 6 over 7 plus times that 5 over 6. Remember, when you go along the branches, you multiply. That's the 10-cent part there. That gives you 5 over 7. Now, $1. I get here 1 over 7, that's 50 cents here, plus this 50 cents, but here's 0, so 1 over 7 times 0, obviously that just gives you 0. Okay, so those two, the coins, 2 coins can obviously not give you, or the total coins cannot give you $1 there, all right, total value of 100 cents. Okay, then, because remember, we're talking here about 2 coins. So how do you then have 2 coins that gives you $1? When there is only 1 coin that is a 50 cent. So 1 coin out of that cannot give you, the other one is 0. So 1 over 7 times 0 over 6 gives you 0. 60 cents, now for 60 cents, you have to be very careful here. So you take 1 over 7, which is 1 50-cent coin, plus 1 10-cent coin. Okay, that's going to give you 60 cents. Or you take 6 over 7, which is your 10-cent coins here, times 1 over 6, which is this 50-cent coin here. So you multiply along here, and then you add the branches as you go. You get to that answer of 2 over 7. Right, so we have got question 4. Please remember, whenever you are trying to solve a question, I'll suggest that you pause the video and then you write the question down, and then you can continue to complete a tree diagram. Okay, so in a game of change on a machine in a casino, so the probability that the player can win is 1/3, lose with a probability of 2 over 5, or draw. So they didn't tell us what is the probability for draw, but we can simply calculate that one without having any difficulties. So to complete this particular part, we have got 1 over 3 for winning, but we don't have for draw, but we have 2 over 5. So remember what I said, this is supposed to add up to 1. So in order for me to find the missing fraction, it's 4 over 15 and 4 over 15, okay? And what is important, so if you complete, this is also 1 over 3, 1 over 3. And this is 2 over 5 and 2 over 5. What is important with this particular question is that you read it carefully. It says that, and this is the part that maybe students can get confused, you are only allowed another game if you draw. but not otherwise. So when you draw, then they give you another game and you start from the beginning. When you draw again, then you can play a third game. Okay, so when you win, you are done, but losing, you are done. But when you draw, they can give you a second game. So take that into account when we answer the following questions. Right, so we are supposed to find the probability that Agnes, for example, will win after one game. Well, winning after one game is very straightforward. It's just 1/3. But now exactly two games, and this is why it comes very important. When you are told exactly two games, that means then the person should have drawn the game and then the person should win the game, because that is the only condition where you will have the opportunity to play the second game. Okay, and it's very important that you do get that particular question. Then the same applies exactly after three games. That means you must draw the first game to play the second, draw the second game, and now when you win in the third game, so it is that along that you multiply in order for you get that probability of 16/675. Right, so there's a C part to this question. It says, what is the probability that Lance, somebody else now, can continue after three games? And here's the catch. It says can continue after three games. That means he's drawing game number one, he draw game number two, and he draw game number three. So it's that 4/15 essentially that must be multiplied by itself, or you cube it, or you can write it out like that. Either way, you should get to 64 all over 3,375. Please write them as fractions. It's far accurate than try to write them as decimals. Question 5. A bag contains a number of balls, each one colored either red or blue. Then a ball is chosen at random and then put back into the bag. Very important that you understand that. Take it and then they put it back. And they repeat this process several times. Okay, the probability of choosing a red ball is R, so not red, it's 1 minus R. Okay, when it's blue, it will be 1 minus R. Take away the red one, obviously 1 minus the red gives you the probability of choosing a blue ball. Then the tree diagram here obviously represents the situation when the process has been carried out twice. Alright, so express your answer in terms of R. Find the possibility that the red ball was chosen each time. That's red, red, so that will be R times R, which is R squared. Okay, when you go along here, you multiply. So if it's 3 times, R times R times R, R cubed, and so on. Right, so there is a third question. So when they do it 9 times, so you just go along that branch 9 times, that's R raised to the power of 9. Should be straightforward. So if the question says at least one blue ball, there is a possibility that, you know, it's red and blue, but at least one blue, then you take 1 minus the possibility that it's just going to be all red, which we know from our previous answer that if you do red, red all the time, 9 times, it's R raised to the power of 9. So take 1 minus whatever that is going to give you at least one blue, either blue, or blue, red, but that is what we are looking at. Right, question 6 here, the probability that Shaminda uses the internet on any day is 3/5. The probability that DeLuca uses the internet on any day is 3/4. So here's a diagram here that we need to complete. So it's 2 people. So Shaminda, this is 3/5. Remember I said this should add up to 1. So this has to be 2/5. And this is 3/4 here. So this has to be 1/4. Now her probability just stays 3/4, and then uses the internet 3/4, does not use is 1/4. Okay. Now part B says calculate the prob that on any day at least one of the 2 learners uses the internet. So we're going to go for use, all right, or we are going to go, so it's 3/5 times 3/4 plus, so remember you go along, you multiply, plus 2/5 times that 3/4 there, so there has to be a use in there, okay, or you take then 3/5, which is use and not use. Okay, but ultimately I have a better way of doing it. I would just have to take when it's not used at all. So does not, and then I will just say 1 minus does not, 2 over 5 does not, and 1/4 does not. You will still get to 9 over 10. Part C says calculate the probability that Shaminder uses the internet on 3 consecutive days. So uses the internet, that is 3 over 5 times 3 over 5 times 3 over 5, okay, which is 27 over 125.